Question 24 reads, a wire loop of radius 0.31 meters lies so that an external magnetic field of magnitude 0.32 Tesla is perpendicular to the loop. The field reverses its direction and its magnitude changes to 0.14 Tesla in 1.2 seconds. Find the magnitude of the average induced EMF in the loop during this time. So the first step that you want to do is we recognize that this problem is asking us for the average induced EMF. So I already know that ultimately I'm going to have to end with this sort of equation here. But in order to solve using this equation for average induced EMF, I'm ultimately going to need to solve for the change in magnetic flux. So I have the change in magnetic flux equation here, and then also here I have sort of a diagram of the wire loop that we're encountering here. So what I want to do is, in order to solve for the change in magnetic flux, I'm going to need to solve for the initial magnetic flux at time 0, and then solve for the magnetic flux at 1.2 seconds. So I know that magnetic flux is equal to magnetic field times the surface area times cosine of angle theta. So the magnetic field, it tells me, has a magnitude of 0.32 Tesla. 0.32 Tesla. And then I can plug in my surface area, which I'm going to have to solve for using a radius of 0.31 meters. But the surface area for a circle is just equal to pi times the radius, which is 0.31 meters squared, times cosine of 0. And I'm using 0 because cosine of 0 is equal to 1. And so this shows that this is perpendicular. And then so now what I want to do, I can calculate this out, but then I'm going to solve for the magnetic field at 1.2 seconds. So this is equal to, it tells me that the magnetic field is 0.14 T times, once again, pi 0.31 meters squared, and once again times cosine of 0 degrees. So once I get these values, this is actually going to equal 0.097, and then this value is going to equal negative 0.042, and that's because the answer here is actually negative for the magnetic flux at 1.2 seconds, because it tells me that the field reverses its direction. So because of this change in direction, that's how I'm going to get this negative value here. So my change in magnetic flux is my next step. So my change is final minus initial. So my final is negative 0.042 T, or I'm sorry, basically Webers. And then Weber is the unit for magnetic flux, and then 0.097. So my answer for the change in magnetic flux is going to be negative 0.139. And so once I have my value for the change in magnetic flux, I can just plug it into this equation here, and this will be my final step. So n is the number of turns, and so since it's just one wire loop, I'll have a negative 1, and my change in magnetic flux is negative 0.139, and the time that has evolved is 1.2 seconds. So this will ultimately give me a value for the average induced EMF of 1.12 volts. But since it asked me for all the answers are in millivolts, I can easily convert this, and so just by multiplying by 1,000, this gives me a final answer of 120 millivolts. So that means my answer for 24 is C.